For more than 30 years, I have often heard these or similar questions. What is the point of studying space? How do I benefit from knowing things like stars, planets, and galaxies? In this video, I would like to give my personal answers to these questions. First of all, generally speaking, they are right. Astronomy doesn't necessarily have to be useful in every aspect of our daily lives. And most of the time, it doesn't seem to be, at least not at first glance. But if you look closer, you'll be surprised how many times astronomy is part of our lives. Every day. Sadly, most of us are unaware of this. Furthermore, astronomy has the power to enrich our lives in countless ways. It is the oldest, the mother of all natural sciences. This makes it one of the most important cultural heritages of mankind. Today, astronomy is not just the study of the sky, not just stargazing, but an interdisciplinary science. Since the beginning of history, people have looked to the heavens for guidance in the vastness of the oceans, for when to sow their seeds, and for answers to the questions of where we came from and how we got here. It's knowledge that opens our eyes, providing a framework for our place in the universe, and is capable of reshaping our view of the world. When Copernicus claimed that the Earth was not the center of the universe, this sparked a revolution that forced religion, science, and society to adapt to this new worldview. Nowadays, when we talk about astronomy, we usually mean astrophysics and cosmology. As the name suggests, astrophysics uses the methods and principles of physics to study celestial objects and phenomena. It deals with a wide range of questions, such as the origin and evolution of stars and galaxies. But there's also another part of astronomy called cosmology, which addresses the big picture, namely how the universe came into being and what dynamics it is subject to. Astronomy also raises important questions about the nature of life and how it evolves on planets. It also ventures into the microcosm, for example, in its attempts to describe the spectrum of stars or to study the very early stages of cosmological evolution. Astronomy also investigates the origin of chemical elements, fundamental forces, and elementary particles, and even ventures to the limits of what can be described in terms of physics. Astronomy plays a role not only in the natural sciences, but also in the humanities, particularly in philosophy, religion, and art. Astronomy inspires us to reflect about space, time, and matter, and what infinity is. This is where astronomy takes its cue from philosophy. And since astronomy is made by people, it also touches on the disciplines of history and cultural studies, showing us, for example, how scientific worldviews change in a social and cultural context. Of course, we also come to questions of creation, leading astronomy and theology to engage in an exciting dialogue that was often a bitter dispute in centuries past. For many people, this is still the case today. Is there a master plan behind the world, or are we able to explain the universe only with plain laws of nature? The ultimate question about life, the universe, and everything. I am firmly convinced that people need a fundamental understanding of astronomy to gain an overall view of nature and society. The wide range of topics covered by astronomy makes it the perfect subject to integrate into school lessons. The problem, however, is that astronomy is practically never taught in schools. Unlike the holy trinity of natural science, physics, chemistry, and biology, which are mandatory subjects and an integral part of the curriculum today, astronomy is usually not included. In most cases, there are only voluntary elective courses and astronomy as a subject within physics or geography lessons. Making astronomy a regular school subject would promote interdisciplinary learning and thinking. What's more, engaging in astronomy and space exploration would spark an interest in future-oriented technologies. What are the consequences of the neglect of astronomy in our society? The evidence is there for all to see, especially here on the internet, a shocking lack of astronomical knowledge among the people. If you ask people on the street, many of them say they're interested in astronomical topics, of course, but they just don't consider this knowledge to be important or relevant to their lives. They say it's too far away from daily routine. At the same time, many people are unaware of the simplest astronomical facts. They don't even know that the Earth orbits the Sun, that the Sun is only one star among billions in a galaxy, and that our galaxy is just one of billions of galaxies. And when they do learn about it, some don't even believe it. This provides fertile ground for doubting or denying science and for abstruse worldviews, such as that the Earth is flat. And to believe that space and all astronomical discoveries are fakes and lies. In this context, it is often claimed that all images taken by astronomers, both professional and amateurs, are faked, whether they show nebulae, star clusters and galaxies, or the surfaces of distant planets. Many people apparently are unable to distinguish between real footage and CGI images and animations, which are often used in videos for visualization, including my own. The denial of scientific findings touches on the field of conspiracy beliefs and occurs primarily where interest groups seek to deny a scientific consensus in a particular area for personal, political, or fundamentalist religious reasons. Whether the issue is climate change, medicine, pandemics, or the flat Earth is of secondary importance. The crucial thing about conspiracy beliefs, what they are really about, is always the conspiracy. That is, the allegation that a political or scientific elite is deliberately and systematically lying to people. Even the topic of the conspiracy theory is arbitrary and can be exchanged at will. To this end, supporters of the flat Earth, for example, use pseudoscientific arguments. In other words, they can't do without science. However, they invent their own science and weird explanatory models. The important thing is that they contradict the official scientific narrative. It doesn't matter that their explanations don't stand up to scrutiny and can easily be refuted. But even people who don't necessarily deny science often think that astronomy doesn't benefit society. They say that astronomers have nothing better to do than studying stars and galaxies, having philosophical discussions about the Big Bang, posting colorful images on the internet, and driving remote-controlled cars across other planets. And they say that they waste billions doing this, money that could be better spent elsewhere. But is that really the case? Let me explain why this is wrong in so many ways. First of all, as already mentioned, astronomy is closely related to many other sciences, including the holy trinity of chemistry, biology, and in particular physics. For example, every chemist should always bear in mind where the elements of the periodic table originally came from. That these atoms were and still are formed in stellar fusion reactors or in stellar explosions, supernovae and hypernovae. And every biologist should also be aware that life on Earth could only come into being because the interplay of a multitude of complex factors made it possible at all. And most of these factors are directly connected to astronomy and astrophysics. Moreover, physics would be so terribly boring without astronomy. Basically, there is no aspect of physics that is not connected to an astronomical subject. Teachers should take advantage of this to teach physics in an interesting and accessible manner using astronomy. We should keep all of this in mind, not least with regard to the demands that may be placed on young people still at school today in 10 or 20 years. If the development in the education of people should teach us anything, it is that in today's high-tech society, falling behind in an important area of knowledge is unforgivable, and at a given point, it becomes very difficult, if not impossible, to catch up. And as for the costs, whenever the media report on a new major research project, it doesn't take long for voices to be raised in protest at the waste of money. For example, the most expensive project in observational astronomy in recent years is the James Webb Space Telescope. This project had a development and construction budget of around $10 billion. Its predecessor, the Hubble Space Telescope, that has been orbiting the Earth for more than 30 years, was built for about $2 billion. Most other projects, especially in ground-based astronomy, stay well below the $1 billion mark. For comparison, here's a few numbers from other non-scientific areas. In 2023, the U.S. had a defense budget of a mind-boggling $886 billion. That's enough for 88 James Webb or 443 Hubble Space Telescopes. And do you remember the 2014 Winter Olympics in Russia, which cost $50 billion to host? With the money spent on this two-week sporting event, the European Organization for Nuclear Research in Geneva, CERN, could build 13 more Large Hadron Colliders and still have change left over. In addition to all of this, there's another reason why astronomy is an important part of our society. Astronomy is also basic research. When you deal with completely new things, as is inevitably the case in basic research, you also encounter totally new problems, for which you also have to find completely new solutions. In many cases, knowledge gained in this way can also be applied in other fields. Particularly in the last century, astronomy has had an incredible impact on other fields such as optics and data processing. It extends into almost all branches of natural science and, through technology transfer, into industry and even into medicine. Many scientific and technological advances that we use in our daily lives and take for granted today would probably never have been realized without space research. The achievements of scientific and technological development in astronomy, particularly in fields such as optics and electronics, have become indispensable to our lives today, with applications such as computers, communication satellites, cell phones, global positioning systems, photovoltaic cells, and magnetic resonance imaging scanners. And the internet, which science deniers use with dedication to spread their conspiracy theories, would not exist at all without science. Next time you send an email, remember this. Before emails became available to the general public, they were originally used as an internal means of communication for scientific research institutions. Perhaps the most widespread invention to come out of astronomy is wireless local area networking, or Wi-Fi. Developed in 1977, it was originally intended as a way for radio telescopes to transmit data. The same method was applied to data signals in general, particularly those designed to optimize computer networks, which is now an integral part of all Wi-Fi systems. Another well-known example can also be found on your smartphones and tablets. It's the photo camera sensor, a light-sensitive semiconductor chip that allows any form of light to be converted into electrical impulses. It was originally developed for image capture in astronomical telescopes and is known as Charge-Coupled Device, CCD. Within a few years, these sensors had not only replaced chemical film, but were also built into cameras, webcams, and cell phones, used by almost everyone today. And here are two examples from the field of medicine. First, an optical stabilization system originally developed for the Darwin Space Telescope is used today in operating rooms for delicate eye surgery, where the image needs to be stabilized, just as it needs to for the search for extrasolar planets. Secondly, the development of detection sensors for X-rays from celestial bodies has led to new highly efficient imaging systems, including magnetic resonance scan, computerized tomography scan, and other imaging techniques that are, for example, used in cancer diagnosis. In short, astronomy is an important part of our society and by no means unnecessary knowledge. This gives astronomy an educational value that cannot be overestimated. And finally, astronomy can be a new and amazing experience too. Anyone who spent a clear night behind a telescope for the first time, who has wandered over the craggy ridges and crater walls of the moon using a telescope, even a small one, can relate to that. Anyone who has experienced the ballet of Jupiter's 4 largest moons, who has admired the stunningly beautiful ring of Saturn, who gazes into the thousands of stars of the Milky Way to see star clusters and nebulae and galaxies floating in the dark depths of the universe, literally changes his view of the world. Afterwards, you are never the same. And by the way, I promise you, all of this is very real and not a hologram or a projection, as some people claim. The universe is very much greater, more beautiful, and more wonderful than the dumb and low-minded who seemingly prefer to live under a cheese bell would have you believe. In his book, The Pale Blue Dot, the famous author and astronomer Carl Sagan gave us one of the most inspiring illustrations of what astronomy contributes to society. With this, he was referring to an iconic photograph of the Earth, made at a suggestion by the Voyager 1 space probe in 1990 from a distance of about 6 billion kilometers or 3.7 billion miles. To this day, this is still the longest-range image of our planet ever taken. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we have ever known. So, please open your mind and get involved with the most beautiful science of all, astronomy. I wish you all the best, and see you next time.